This is GCSE Further Maths from CCEA, and we're looking through the pure 2019 past paper. So let's take a wee look at question 1. So 1 says the matrices A and B are defined by A and B. Find the value of B minus A squared. So the first thing we're going to have to do is work out our A squared. So our A squared is going to equal 2, 3 minus 1, 4 upon 2, 3 minus 1, 4. Again, we should know this because they're square matrices, but it's a 2 by a 2 and a 2 by 2. So our result then is going to be a 2 by 2. So we're going to do then first row times the first column to get the one on the first row in the first column. 2 times 2 is 4. Take away 3. So that's a 1. First row, second column, 6 plus 12 is 18. Second row, first column, minus 2 minus 4, so that's minus 6. And then second row, second column is minus 3 plus 16, so that's 13. So that's our A squared. So our B minus A squared is then going to equal 1 minus 2 minus 3, 5, subtract 1, 18 minus 6, 13, and the result then is going to be 1 take away 1 is 0, minus 2 take away 18 is minus 20, minus 3 minus minus 6 is 3, and then 5 take away 13 is minus 8. So just put our answer then down where it says answer. So we have 0 minus 23 minus 8. Question 2. A function f of x is defined by f of x equals x squared minus x plus 4. Use the method of completing the square to rewrite f of x in the form x plus a squared plus b, where a and b are constants. So we're going to take half of this x term here, so that's a 1, so it's going to be a half. So we want to consider, and I do this over to the side, x minus a half all squared. That equals x minus a half upon x minus a half, and using FOIL then gives me x squared minus a half x minus a half x minus x, which is what we want, and then minus a half times minus a half of course gives us plus a quarter. So therefore our f of x, which as we know in the question equals x squared minus x plus 4, then is going to be x minus a half all squared, and we want to make this look like this. So this here is this, so we have the x squared, we have the minus x, but this generates a quarter that we don't want, so we need to do minus a quarter plus 4, and to tidy that up, x minus a half all squared, and then plus 15 over 4. Again, put it in with it. As for the answer, so x minus a half all squared plus 15 over 4. Hence, find the minimum value of f of x and the value of x for which that occurs. The smallest number this can be is 0. You can't get anything smaller than 0. If you stick in a big negative number into that, once you square it, it becomes really big. So the smallest number is 0, and that happens whenever x is a half. That means the smallest number for this whole thing then is going to be 15 over 4. So our minimum value is 15 over 4. And as I said, that happens whenever this bit equals 0 and this bit equals 0 whenever x is a half. Question 3. Find dy by dx if y equals 3 over 8x squared plus 5 over x to the power 4 minus 12x. Before I differentiate this, I want to get it in the form like this, plus 5x to the minus 4 minus 12x. I hope you're okay with what I've done there. I've brought the x to the 4 up to the top to make it easier to differentiate. That's going to give me dy by dx So take away 1 from the power and multiply by the whole power. So that's going to give me 6 over 8. So that would be 3/4 x. What's going to happen here then? The minus 4 times the 5 is going to give me minus 20, and then take away 1 from the power, x to the minus 5, and then differentiating this gives me minus 12. That does give you full marks according to the mark scheme. Some people like to bring this back down to the bottom again, and our answer then would be dy by dx equals 3/4 x minus 20 over x to the 5 minus 12, and both of those are fine. Part B, integration then, and again I want to take this x squared out separately, so I haven't integrated yet, so my integral sign remains, and it's 3/4 x to the power of minus 2 x cubed. 3 over 4, add 1 to the power minus 1 and divide by the new power. That's simply going to turn that into a negative. Take away 2x, add 1 to the power and divide by the new power, and then plus c. So again we could take this down to the bottom if you wish, or we could write it as minus, I would want this tidied up effectively, so it's minus 3/4, or 3 over 4 x is fine, minus a half x to the power of 4 plus c, and I'm happy enough then to write that in where the answers are. Question 4a, sketch the graph of cos x for between minus 90 and 360. So this would be our minus 90 here, that's obviously 0, 90, 180, 270, 360. That would be a 1, and that would be a minus 1. So hopefully we're okay with what the graph looks like here. You can have your 1 there if you want, but our graph of cos looks like this. It's not a great curve actually, it's one of the bit more curvy looking, especially on the bottom bit. And we have that, they've asked in for this other bit here, so it just repeats itself and then comes back down to here. So that's my graph of cos. That's not great, I wouldn't mind more of a curve going along there, but nevertheless that's okay. B, part 1, solve the equation cos x is minus 0.184, that's between 0 and 360, give your answers in the 1 decimal place. So the way I tend to do this is I ignore the negative and find what I call the basic angle. So I would have cos x is 0.184, x then is cos to minus 1, 0.184, so shift cos 0.184, brackets, and that gives me 79.397. I then do my cast diagram. 0, 90, 180, 270, 360, C, A, S and T, and I put on my basic angle here, which I'm going to go for as then 79.40. I want to know where cos is negative, and cos is going to be negative here and here, so I need to find those angles there. That's 79.4, that's 79.4. So can we see what this angle is going to be? It's going to be 180. Take away 79.4. So if I have x equals 180 minus 79.4, and that gives me 100.6. And then how do I get this one here? So that would be 180 plus 79.4. And that gives me 259.4. So the two angles I want then are 100.6 degrees or 259.4 degrees. Okay. Hence, solve the equation cos 2 theta minus 15 equals minus 0.184. Give your between 90 and 180. Give your answer correct to 1 decimal place. So we simply look at our previous question and we exchange our x value then for 2 theta minus 15. So 2 theta minus 15 is equal to 100.6. Having 15 to both sides, 2 theta is 115.6, and that means theta gives me 57.8. Now that's no good to us because it's not between 90 and 180 degrees, so that's outside our range, so we can't have that one. Let's try it then for the other one. 2 theta minus 15 is 259.4. 2 theta is 274.4 by 2, 137.2. So that one works. That is between 90 and 180 degrees. So my answer then is going to be 137.2 degrees. Question 5, matrices P and Q are defined by P and Q. Use a matrix method, find the matrix X such that Px equals Q. So that means minus 3, 2, 1, minus 4 times by X. I did that last time. Don't need the bracket here. Equals 7, 1. This was a normal equation. I wanted to divide both sides by this. You can't do that with matrices, so we need to find the inverse of P. So the inverse of P is going to be 1 over the determinant upon change these two around. Change the signs of these two. My determinant of P is AD, which is 12, take away 2, and that gives me 10. I'm now going to multiply through both sides, so therefore P to the minus 1 is 1 over 10 minus 4 minus 2 minus 1 minus 3. So I'm going to multiply both sides of this equation here by this. So it's going to be a 10th upon minus 4 minus 2 minus 1 minus 3 minus 3, 2, 1 minus 4 x is a 10th minus 4 minus 2 minus 1 minus 3. Just about fit it in here, 7, 1. This gives me a 10th, a 2 by 2, 2 by 2, so I have a 2 by 2. This is in the first row and first column. So I do 12 take away 2, which gives me 10. You should know what I'm expecting here anyway, I hope. First row, second column, minus 8 plus 8, that's 0. Second row, first column, 3 minus 3 is 0. Second row, second column, minus 2 plus 12, and that's 10, and that's x. A 10th. This is a 2 by 2 and a 2 by 1, so my result then will be a 2 by 1. Minus 28 minus 2 is minus 30. That's encouraging because it does divide by 10. Minus 7 minus 3 is minus 10. So we're pretty much there. Hopefully you can see what happens here. This 10th multiplies through here to give me the identity matrix. That means this disappears, and it gives me then x is minus 3 minus 1. Question 6, solve the inequality x squared minus 4x minus 5. You must show clearly each stage of your working. We can do this a couple of different methods. I might do it twice actually, so we'll go for method 1 here. And method 1 is just a quick sketch of the graph. So I'm going to let y equal x squared minus 4x minus 5 and sketch the graph. Where it cuts the x-axis are really important bits here, and that's whenever y equals 0. So it gives me x squared minus 4x minus 5 equals 0. And then for two numbers I multiply to get minus 5 and add to get minus 4. That's going to be minus 5 and plus 1. That gives me then x is minus 1, or x is 5. And that's enough then to draw enough of the graph that I need. I can see from this graph it has to be a U shape as opposed to an N shape because it's a positive x squared term. And I can draw a wee graph then from here. So just a quick sketch is all that's required. Minus 1 and 5. Something like that is good, with my x-axis here and my y-axis here. Now back to the question. They're asking where is x squared minus 4x minus 5 less than 0? This is the tough bit. That's asking the same thing as where is this line below the x-axis? This line is below the x-axis in between here and here. Therefore x has to be between minus 1 and 5, and that's the answer. Method 2, you can use a table. Again, we would do the same thing. You kind of do x squared minus 4x minus 5 equals 0, and we get then x is minus 1 and x is 5, and I split up all the numbers on the number line according to those values. I take my two factors again. I should have a wee line there, the x plus 1 and the x minus 5. So x plus 1, x minus 5, x plus 1, x minus 5. Anything less than minus 1, anything in between minus 1 and 5, and anywhere where x then is greater than 5 are the bits that I want. I pick a number less than 1, for example minus 2. That's negative. That's negative. And negative times a negative, because I'm multiplying this by this, gives me a positive. In between minus 1 and 5, so let's pick 0, that's positive. That's negative. A positive times a negative gives me a negative. Anything bigger than 5, 6. 6 plus 1 is 7, so that's positive. 6 take away 5 is positive. Positive times a positive gives me a positive. The question asks, where is this less than 0? That's the same thing as asking, where is this negative? So this is negative here. So my answer is minus 1 as an x less than 5. Question 7 is solve the following simultaneous equations. Quite a straightforward one, to be honest, I think. So let's take a wee look, we can get some answers. So this, and this, I'm going to of course call those 1, 2 and 3. And I guess I'm torn between the x's and the z's, but I think I'll go for the z. So I'm going to make the z's the same as each other. So what am I going to do? I'm going to times this one by 2 and then subtract number 2. So 2 times number 1 gives me 4x plus 6y plus 2z equals 10. And then equation 2, 3x minus 4y plus 2z is minus 9, and I'm going to subtract those. That gives me x plus 10y equals 19, and I'm going to call that equation 4. I'm now going to do equation 1 times 3 and then add it to 3. So that's 3 times 1, 6x plus 9y plus 3z is 15. And then of x plus 5y minus 3z is 6. And I'm going to add those two. That gives me 7x plus 14y equals 21. And I'm going to call that equation 5. So 4 and 5, I'm going to solve them to work out my x and y. What am I going to do? I'm going to times number 4 by 7, I suppose. So if I go for 7 times number 4, that will give me 7x plus 70y equals 19 times 7. I should know that. 133. And then I'm going to do this one, take away this one. I should possibly have written that out below, but that's okay. So this subtract this is of course 56y, and that gives me then 112, and I get a value of y equals 2. If I substitute then in the 4, which is then x plus 10, y is 19, is x plus 20, sorry, that's be a plus 19, so my x value then is minus 1, and then finally sub back into 1, 2x plus 3y plus z equals 5. X is minus 1, so it's minus 2 plus 6 plus z equals 5. I rearrange that and I get z equals 1. So my three values then are x is minus 1, y is 2, and z is 1. Just one more thing, they do give you another page for your working out, so please don't be sort of trying to squeeze it all into the one page. They're normally very good at giving plenty of space for this. This is question 8. A curve is defined by the equation y equals x upon 3x minus 5 upon x plus 1. Write down the coordinates at the point where the curve meets the y-axis. So crosses, I think I said y, I meant x, x-axis whenever y equals 0. That means x upon 3x minus 5 upon x plus 1 equals 0. This is already factorized for us. That means either x is 0, 3x minus 5 is 0, and x plus 1 is 0. That means that x then is 5 over 3, or then x is minus 1. So my coordinates, what they've asked for, then are going to be 0, 0. 5 over 3 and 0 and minus 1, 0. Find the coordinates of the turning points of the curve. So y equals x, 3x minus 5, x plus 1, and I need to multiply that out because I need to differentiate it to find my turning points. So it's x upon 3x squared minus 5x plus 3x, so it's minus 2x, then minus 5, and my curve then equals y is 3x cubed minus 2x squared minus 5x. I'm ready now to differentiate. 3 times 3, 9, x squared minus 4x minus 5, and at a turning point dy by dx equals 0. So we're going to try and solve 9x squared minus 4x minus 5 equals 0. 9 times minus 5. So multiply to give me minus 45 and add and to give me minus 4. So I'm going to split my middle term. What are the two numbers? They're going to be minus 9 and 5. So I'm going to have 9x squared minus 9x plus 5x minus 5 equals 0. Do my line down here. I can take out a 9x, x minus 1 plus 5x minus 1 equals 0. 9x plus 5 upon x minus 1 equals 0. That means 9x plus 5 equals 0, or x minus 1 equals 0. So x is minus 5/9, or x is 1. We now need to find our y coordinates, and I'm not going to do this, but you can just plug it in to your calculator. So we would substitute minus 5/9 into this here. You could substitute it into this if you want, it's going to give you the same answer, but minus 5/9, if you substitute that in there, is going to be, there we go, it ends up giving you a real number of 400 over 243, which again you could write the two decimal places if you want. And if you substitute the 1 in, let's just do that anyway. So 1 cubed, so it's 3, take away 2, take away 5. So that's going to be minus 4. Move back up here so you can see. So that means my coordinates are minus 5/9, 400 over 243, and 1 minus 4. And they will accept that as things to two decimal places in as well if you wish. So that will be minus 0.56. It's going to help if we have a graph to draw as well. 1.65. So that's safe. Using calculus, identify each turning point as either a maximum or a minimum. You must show working to justify your answer. So we need to find in d2y by dx squared. So we're going to differentiate our term again. So it's 9x squared, so it's going to give us 18x whenever we differentiate that. Minus 4x gives us minus 4, and the 5 then is just going to disappear. When x equals 5/9, we are going to have divide by 9 multiplied by, so it gives me 2 times the 5, isn't it? So that's a 10, take away 4, is that a 6? I think. Minus 5/9. When x is minus 5/9, sorry. Yes, of course. It's a negative. d2y by dx squared gives us then minus 14, which is less than 0. And that means that one's a maximum. Whenever x equals 1, d2y by dx squared, 18 times 1 is 18, 34 is 14, which is greater than 0, which then is a minimum. So there's a maximum at minus 0.56, 1.65, and there is a minimum at 1 minus 4. Finally then, sketch the curve on the axis below. So where does it cross the x-axis? It crosses at minus 1, and then 5 over 3. So it crosses minus 1, 5 over 3, which is 1 2/3, obviously, 5 over 3, and 0. My maximum is minus 0.56, 1.65. About here. And my minimum is 1 minus 4. So 1 and then we join those points together then with our curve. So we have something like that. Apologies for the long gap there. I thought I had paused the video, but I hope you enjoyed that. 2 log y equals 3 log x for question 9. Using our laws of logs, we could rewrite that as log y squared equals log x cubed. If that's the case, we can remove the logs and we can get y squared equals x cubed. And then we would take the square root of both sides, so that would be y equals x to the power of 3 over 2. If 4 times 2 to the power of x equals 2 to the power of y, show that y equals x plus 2. We want to change everything here into powers of 2. So that left hand side is going to become 2 squared times 2 to the power of x equals 2 to the power of y. Using our rules of indices, that's the same as 2 to the power of 2 plus x, because you add the 2 powers, remember, equal 2 to the power of y. And then that gives me 2 plus x equals y. Part 2. Hence or otherwise solve the equation. 3x is 2. That's the same as 2 to the power of x plus 2 from what we worked out earlier. Then we can have 6 to the power of 3x minus 2. And this is a reasonably standard log question then from here. So we take logs of both sides. So it's log 6 3x minus 2 equals log 2x plus 2. Multiplying out our brackets. 3x log 6 minus 2 log 6 equals x log 2 plus 2 log 2. Anything with an x I'm taking to this side, anything without an x I'm taking over to this side. So I have 3x log 6 minus x log 2 equals 2 log 6 plus 2 log 2. I want to factorise out the x upon 3 log 6 minus log 2 equals 2 log 6 plus 2 log 2. X equals 2 log 6 and if you put that into your calculator, you will get x equals 1.06. I'll definitely try and pause this time. Question 10. Rory has a set of objects with a circular base who records a base radius r in the volume of the objects. Results are given in the table below. Rory believes a relationship with the form v equals a r to the b exists where a and b are constants. Verify the relationship exists by drawing a suitable straight line graph on the graph opposite. show clearly the values used correct to 3 decimal places in the table above, hence find the values of n, b correct to 1 decimal place. So if we work out our log r and log v, put in your calculator log 3.4, 0.531, log 4.6, 0.663, 0.716, 0.833, 0.875, then 1.991, 2.346, 2.490, 2.804, and 2.919. Down below we need to rearrange this to get in the form we want, so it's v equals a r to the b, and that is log v equals log r b plus log a. Hopefully you're okay with it done. I've kind of switched those two around because of the way we want it. And then log v equals b log r plus log a. So this is now in form of y equals mx plus c. And so if we plot log r against log v, we would hope to get a straight line. So here is our scale, so we're going to go for, along the bottom is log r, because it's our equivalent of x, and up the side then is log v. We need to go kind of from 0.5 to 0.9, so 0.5, 0.6. So go for that 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. Here we need to go from like sort of 1.9-ish up to 3. So if I go 1.82, so if that will work 1.8, 2.0, 2.2, 2.4, 2.6, 2.8, and then 3.0. For my first one is 0.531, so there's 0.531, and then 1.991, so we're very, very close. So 0.9, so I think somewhere around there is pretty decent. 0.663, so there's 0.66, so 663 is a bit further along than that, and then there's 2.346, so there's 2.2, so there's 0.66, there was 2.2, so 2.3 here, so 2.246, somewhere I think around about here. Our next one 0.716, so there's 716 is slightly closer to this, hopefully up around here. It is 2.490, so that would be 2.48, and that would be 2.52, so 2.490 possibly round about here. 0.833, so it'll be up around here, and that is 2.804, and then our final one 0.875, so there's 0.875 exactly there, and 2.919 again around about that, so it's looking quite like a straight line graph to me. So that is our straight line, therefore relationship verified. I'm then going to use my previous data to work out the gradient, which is going to help me work out the b. So my gradient, which is b, and the points I'm going to take, 2.919, I'm going to take this value here, and I'm going to take this value here. It's fairly standard. Remember, that's your x, that's your y, so it's y2 minus y1 over x2 minus x1. 2.919 minus 1.991 all over 0.875. That's my x2. Take away x1, 0.531. And that gives me 2.698. What's this round about then? 2.7 if you're going to one decimal place. If I'm using the value again, I'll use this one. To work out my value of A, I'm going to go back then to the original data, and so I'm going to use then the 3.4 and the 98 and use V equals A R to the power of B. V equals A R to the power of B. So that is 98.0 equals A upon 3.4 to the power of 2.698. So hopefully you can see what you do. 3.4 to this power, you put that in your calculator, and then you divide through. You get A then is 3.6. That's the one decimal place. Should fill those values in below. And then 2.7. Getting there. So let's see what we get asked next. Use the formula V equals A R to the B with your values for MB to calculate the volume of an object with radius 5.6, giving your answer to the nearest centimetre cubed. So we are going to be using V equals 3.6 R to the power of 2.7. V equals 3.6 upon 5.6 to the power of 2.7. And if you put that in your calculator, so remember that isn't to the power of 2.7, it's only the 5.6, then you times by 3.6 at the end, we're going to get 377 centimetres cubed. The diameter of an object with a volume of 1,000, so that means 3.6 R to the 2.7 equals 1,000. R to the 2.7 equals 1,000 over 3.6. You can do this by logs if you wish now. And so, say this was R to the power of 4, we would take then the 4th root of this to get our answer. If it's R to the power of 8, we would take the 8th root. It's R to the power of 2.7, so we would take the 2.7th root. So we would go R equals 1,000 over 3.6 to the 1 over 2.7. That gives you a value then of 8.037. That's not right. That gives you a value of 8.037, and of course that's the radius. So for the diameter, 2 times the radius, and so that rounds fairly closely then to 16 centimetres. The usual assumption, you know, often get asked this at the end, but it's just the relationship holds outside the range. And that's us for that question. Question 11 then, find the equation of the normal to the curve y equals 2 minus 3 over x. So it's going to be y equals mx plus c. We need to find their gradient. So we're at the point where the curve cuts the x-axis. So this is some curve and it cuts the x-axis. How do we work out where it cuts the x-axis? It cuts the x-axis whenever y equals 0. If I put y equal to 0 here, I get 0 equals 2 minus 3 over x. That means 3 over x is 2 times by x divided by 2. I get then x is 3 over 2. So that's the value I'm going to put in then for dy by dx, but it cuts the x-axis at 3 over 2, 0. I need to find dy by dx, so I want to rearrange my y. So y equals 2 minus 3x to the minus 1. That means dy by dx, that disappears. Multiply by the whole power, so it turns into a positive, so it's 3x to the minus 2. Quite often it's easier, if you do change this background, it's just easier to substitute numbers in. So we'll give you 3 over x squared. We want to know the gradient whenever x is 3 over 2. So 3 divided by 3 over 2 squared is 3 over 9 over 4. So that's going to be then times by the 4, you get 12 over 9. And that cancels down then to 4 over 3. That would be the gradient of the tangent at that point. Therefore, gradient of normal would be the negative reciprocal, so minus 3/4. So that means we know y equals minus 3/4 x plus c. And we're going to substitute in the point 3 over 2, 0 to get our c. 0 is minus 3/4 upon 3 over 2 plus c. That then gives me minus 9 over 8, so my c then is 9 over 8. Therefore, equation of normal is y is minus 3/4 x plus 9 over 8. Question 12 then, expand and simplify the following expression. So I would tend to do x plus 3 and then do FOIL for this bit here. So x times 2x gives me 2x squared. The outer and the inner are going to be 5x minus 8x, so it's minus 3x, and then minus 20. I then want to multiply all of this by x and all of this by 3. Multiplying it all by x gives me 2x cubed minus 3x squared minus 20x. Multiplying it all by 3 is plus 6x squared minus 9x minus 60. So tidying it all up gives me 2x cubed plus 3x squared minus 29x minus 60. So just write that in where the answer is. So 2x cubed plus 3x squared minus 29x minus 60. Hence, simplify fully this expression here. This is the thing we've just multiplied out, and then this needs tidied up as well. So if we look at our numerator, let's see if we can tidy it up. So we're going to get, then what was that? That was 2x cubed plus 3x squared minus 29x minus 60. Take away 2x times the x squared. So take away 2x cubed plus 4x. Do you know what? That's minus 4x, sorry. Minus 4x and then minus 18. That's all over x squared minus 13x. So tidying that up, 2x cubed, take away 2x cubed, that bit just disappears, so that's good. 3x squared stays on its own, so that's 3x squared. Minus 29x minus 4x is minus 33x. Minus 60 minus 18 is minus 78 all over x squared minus 13x. This here, there's a common factor of 3 to come out, and then we might be able to factorize it. This here, we can take out an x. So let's start to tidy it up and see where we go. X squared minus 11x, and a third of 78 then is 26 all over x upon x minus 13. I suspect there's going to be an x minus 13 here, so we'll see how we go. We're looking for x minus, two numbers and multiply to give minus 26 and add to give minus 11, so it's of course x minus 13x plus 2. That cancels with that, so that gives me then 3 upon x plus 2 over x, which would get you full marks, should be no issue with that. Or you might want to multiply the bracket, giving you 3x plus 6 all over x. Question 13, in the diagram below shows some sketches of the curve y equals k plus 2x minus 3x squared, here and here. Find expressions in terms of k for the area of A and the area of B. Well, the way we find our areas under curves is to integrate. So we're going to have to integrate them between 1 and 0. I hope you can see that. So the area of A, I'll move this up in a wee second, is equal to the integral between 1 and 0 of k plus 2x minus 3x squared dx. So integrating, the k is just a number, so that becomes kx. You know, if you integrate like a 4 or something, that would become 4x, so it's just kx. Plus x, 2x add 1 to the power is 2 divided by 2, so that's just plus x squared. And then minus add 1 to the power divided by new power, so it's just x cubed. And between 1 and 0, if we substitute the number 1 in there, I get k plus 1 minus 1. If I substitute 0 in there, that then just gives me k. For the area of B, it's between 2 and 0, so it's the integral between 2 and 0 of k plus 2x minus 3x squared dx. Of course, you just get the same thing, you know, whenever you integrate. We just want to sub in the number 2 instead, so kx plus x squared minus x cubed between 2 and 0. If I substitute in 2 here, I get 2k plus 4 minus 8, and then take away 0. That gives me 2k minus 4. So I might just substitute those answers in there. The area of A is just simply then k, and the area of B is 2k minus 4. Given that the area of A is 5/9 the area of B, find the value of k. So let's write that in some sort of equation. Area of A is 5/9 the area of B. That means k is 5/9 upon 2k minus 4. I could times both sides by 9. 9k equals 5 upon 2k minus 4. 9k equals 10k minus 20, and rearrange that. That gives you k equals 20. The owners of a hotel wish to build a swimming pool in the hotel grounds. They plan to build a rectangular pool A, B, C, D for adults of length x and width y. At one end of the pool they plan to build a children's pool y over 3, x over 3. The length and width of the pool are a third of the length as shown respectively. Write down in terms of x and y the total area of the two pools. So it's going to be this one here plus this one here. So area is equal to xy, that's the big pool, plus x over 3 times y over 3, that gives me x, y over 9. Those are both like terms, that's an xy, and that's like a ninth xy, so it's going to be 10 over 9 xy. My light robot out here. See what I was trying to write down here, so 10 over 9 x, y. The total length of the perimeter around the outer edges of the pools. Right, that's an x, and then that one and that one is going to give me an x, so that's 2x. That's a y, and that's a y, so plus 2y, and then I need to add those, plus 2y over 3. Let's write that over here. So my perimeter is 2x plus 2y plus 2/3 y effectively. 2x, so that's 6/3 y plus 2/3 y, so that's 8 over 3y. The total length of the perimeter around the outer edges is 96. Show that y equals 36 minus 3/4 x. So the perimeter, I'm a bit mixed up here, 2x plus 8 over 3y, and we're saying that that is equal to 96, and we're trying to get the y on its own, and hopefully if we get the y on its own, then will give us that. So I'm going to times through everything by 3. That gives me 6x plus 8y equals 96 times 3. So that would be what, 288, I think. If I divide now everything by 8 to get the y on its own, I would get 3/4 x. Is that okay? So it's 6 over 8. And then just simply rearranging that. I get y equals 36. Take away 3/4 x. Find the dimensions of the pool which will give the maximum total area, showing that it is a maximum. So my area of the pool, I need to go down here, it was 10 over 9 xy. That means my area of the pool is 10 over 9x upon my y. I had arranged for 36 minus 3/4 x. We're not dealing with very nice numbers here, but we should be okay. Divide by 9, so multiplying through might be 10 over 9 here, so divide by 9 gives me 4. So that's going to be 40x, keep my a in here, and then 3/4 times that, so that'll be a 3 on the bottom and 5 over 2 on the top, minus 5/6. And that's not as bad looking now. If we're trying to maximize this, I want to differentiate. So I get dA by dx equals 40. Two times the 10, so 10 over 6 x for a maximum. Then dA by dx equals 0. So that means 0 is 40 minus 10 over 6x. Or if you want 10 over 6x equals 40 times the 6 by the 40, you get 240 divided by 10. So that means x is 24. If x is 24, then 36 take away 3/4 of 24, so 36 take away 18 gives me 18, so my y then is 18. I need to show that it is a maximum, so I need to find in d2a by dx squared. Keep this bit separate. That gives me minus 10 over 6. The 40 disappears. And 10 over 6, of course. So minus 10 over 6 is less than 0. Therefore, it is a maximum. The adults pool then, what are the dimensions? They are 24 by 18. And remember the children's pool then was a third of that. So a third of that is 8. And a third of that is 6.